All right, you guys. So now I'm going to put you guys on some geometry stuff. So you see that this is geometry up here. It talks about the Pythagorean theorem and its converse. So we're going to go a little bit further into the Pythagorean theorem and see what we can do with that. So these first four problems, what I want you to do with this worksheet is I just want you to do each problem, right, and try to do all of them. I'll kind of work through a couple of these at the end just to give you an idea of how to do them. And then we'll be done after that. So these first four, just using the Pythagorean theorem, so I'm not going to go over those, but the a squared plus b squared equals c squared. Make sure that you put your hypotenuse, so the one that is across from the right angle, in for c, right? Even though they're using x here this time, right, you can still use the a squared plus b squared equals c squared. And then you would just round your answer to the nearest tenth if you need to. So if you have to take the square root and it's not a perfect square, just round it to the nearest tenth. After that, this one right here, still using the Pythagorean theorem, but it says leave your answer in simplest radical form. So for example, for this one, or let's say not for this one, let's say I just give you a random number here. So let's say our answer came out to be in this, it does not come out to be this, so don't put this down as your answer. Let's say it came out to be the square root of 40, right? So let's say you had to take the square root of 40. Up above, we would have then taken it to the nearest tenth, but they want us in simplest radical form. So we then have to go back to simplifying square roots. And we'd say, okay, what perfect square goes into 40? Or what's the largest perfect square? Because sometimes we have more than one perfect square that goes into 40. Well, in this case, it'd be 4 times 10, right? So square root of 4 times the square root of 10, that still ends up getting me the square root of 40. I know the square root of 4 is 2, and then it'd be times the square root of 10. And again, that's not my answer for number 5, but again, that's what they're wanting you to do. If you end up with a square root that's a non-perfect square, then you just simplify it like we did earlier on in the year. So that's for both of these. You would try your best to simplify those and write your answers in. If I close this out, I can scroll down a little bit more. Here is, they give you missing side lengths. C is the hypotenuse, is what they say right here. So for number 7, they give you the hypotenuse, so you'd put that in for the c squared. And then c is right here is 4. Now the only difference here is when I set this one up, let's say I just set number 8 up with you. If I write this out, it'd be a squared, we don't know what a is, plus, and I'm going to put this in parentheses. There's a reason why I do this, the square root of 6 squared, because that's what b is, equals 4 squared. Again, that's a 6 right there. Now, the reason why I put this in parentheses, because we know here that even though this length is a square root of 6, we don't want to take it to like a decimal. Let's just leave it like that. This square root cancels out with this squared. So really, I'm looking at this equation. A squared plus 6, because those two operations cancel each other out. Let's make that look more like a 6. Oh, man, this is not the easiest thing to do here. And then equals 16. So I would solve that then to get my final answer. And it wants it again in simplest radical form. So again, we're going to have a non-perfect square here. We'll then have to simplify that at that point. And if you can't, if there's not a perfect square that goes into it, then just leave it as is. Leave it as the square root of whatever number. So I'll close this out and I'll scroll down. Here is the converse of the Pythagorean theorem. So this is taking all these numbers and seeing if they balance out, right? So I'd have to use the a squared plus b squared equals c squared. So we would assume that if this is a right triangle, that the right angle is right here. So this is my hypotenuse. So I'd write this out as 9 squared plus 12 squared. Those are my two legs of the triangle. And then equals 15 squared. If that balances out, right, if both sides of the equation equal each other, then it would be a right triangle. If they do not equal each other, then that means it's either acute or it's an obtuse triangle. And I'm going to show you how to figure that out right after this. So you would solve this side, then solve this side, and you would see if it ends up equaling and balancing out on each side. So that's for 9, 10, 11, and 12. Just be careful when if you're going to use a calculator, putting this into your calculator. If I were to actually square this, you could actually just say 2 squared times square root of 39 squared, right? Which 2 squared is 4. The square root of 39 squared is just 39 because it cancels out just like that other one up above. So just making it a little bit more challenging on you, getting these different types of irrational numbers in here to have you work with. Be careful when you type everything into your calculator if you're going to use a calculator for this, because calculators can make mistakes. Put parentheses where they need to go. This 13 and 14 is still the same thing. Just make sure when you're putting these numbers into the Pythagorean theorem, the largest number always goes in for C. So that's my C value right there. This is my C value. And again, you're just seeing if it balances out each side. Okay? And then here it is, obtuse, acute, or even right. So those ones up above, we were just figuring out, are they right triangles or not? But then if they're not a right triangle, so if you said no to some of these up above, then we can figure out whether they're acute or obtuse. And I'm going to switch my screens here real fast, and I'll come back to one of these. So for example, if I full screen this and we look at this, if you have the 3 sides, which we are given the 3 sides in those previous examples, if right here, this part, if c squared equals a squared plus b squared, then it's a right triangle. So that's what we were figuring out up above. But let's say it wasn't equal. Well, if the c squared is less than the a squared plus b squared, then it's acute. If the c squared was greater than that a squared plus b squared, then it's obtuse. These are some notes that you could write down. So you could pause this video right here and you could write some of this down. And this is just going to be another theorem that you'll learn in geometry next year. But again, it's a part of algebra too, because we're using algebra to solve these. So if I go back, let's look at one. So again, if the c squared is less, it's acute. If the c squared is greater than, it's obtuse. So if I go back here and let's look at this one. So let's say I set it up. And I would say, all right, what is if it was a right triangle, my hypotenuse, my C would be 17, because that's my largest. So it's 17 squared equals 9 squared plus 12 squared. Now, at this point, I would have to get all these numbers. So 17 squared is 289, right? So I would put that in there. So 289. And then does it equal 81 plus 144? Well, 81 plus 144 is 225. And it is not equal, right? So this 289 is my c squared. So since this side is larger, right? So the c squared is larger. If we go back to this, the c squared being larger makes it an obtuse triangle. If it was equal, it would have been right. And if the c squared was less, it would have been acute. And we could then go on. Whoa, whoa, whoa. That is terrible. All right, so it'd be obtuse. Okay? And then we would go on and figure out, hey, is this obtuse, acute, or right? We would then go on to see if these are acute, obtuse, or right. And again, be careful when you're evaluating that number in your calculator. Be very careful with this. These ones you can just put in, but make sure, I would always put parentheses around the numbers when I'm squaring them. So you do these 18 problems, they'd be really good practice for you, making it a little bit more challenging because again, we are in geometry. If you have any questions, let me know.